So in this video, we're going to look at adding and subtracting fractions. Now, with multiplication and division, we didn't really have to change much before doing the operation. However, with adding and subtracting fractions, we need something to be true. We need the same denominators. So, with that, we might have to do some extra steps in order to create the same denominators. So we're going to look at both cases. What you can see is up here, we're going to deal with same denominators with addition, subtraction. Then we'll see what happens down here when we have different denominators. So when they're the same already, there isn't much we need to do. Now, in terms of combining them, what we're going to do is combine the numerators. So like this one's addition. So we're going to add those numerators together. And then what we do with the denominator is we just keep it. We keep the denominator that we're working with. So that means I would keep that denominator of 13. Because visually what we're doing here, and this can be kind of tricky to draw with 13 pieces, so I'll do my best here. Let's say we have something with 13 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I think I did it. So the idea is we have 6 of these pieces. 1, 2, 3, 4, 5, 6 of these 13ths. And what we're doing is we're adding on 5. 1, 2, 3, 4, 5. So the idea being is we're still working in 13ths. That's still our whole here. We still have the same whole that's divided up in 13ths. But now what we have is a total of 11 pieces. So that's where we add the numerators together and then keep the denominator of 13. So now we can see what parts do we have of the overall whole. Same thing is true with subtraction. If we have the same denominator, then what we're doing is we're combining the numerator and then keep that denominator. So we're going to have 11 minus 7 over 15, which is going to be 4 over 15. Now with these, also take a moment to see if you can simplify any further, which in this case we can't, so we're going to keep it just like this. If you're unsure whether or not it would simplify, so let me make this a little different. Let's say this was 12 over 15. And you weren't sure whether or not that would simplify. I want to show you how the calculator can help you out here. So in the calculator, let's say I type in that 12 over 15. What it will show you is the decimal form there, but with a lot of our work, especially for calculating with fractions, we want to keep it in fraction form. To answer in decimal form is to change into a whole different kind of realm of numbers, and we don't want to do that. If we're working with fractions, we want to keep it as fractions. But what you can do is use the Desmos calculator to help out with simplifying, and that's with this button over here. It says convert to fraction, and what it will do is it will always give you the simplified form of your fraction. So use that to help out to double check. The number we're actually working with is 4 out of 15, which if you look at the converted fraction is exactly the same, and that just tells me there's nothing to simplify there. So we're not using that number, we're using this number, but you can use the calculator to help simplify. Okay, so what if the denominators are not the same? What we need to do is create equivalent fractions, which we looked at in the last video. So the idea is working with equivalent fractions. Simultaneously, we're thinking about the least common denominator. Now the least common denominator is basically the smallest value that both of these numbers can multiply up to. There are a few different explanations of it, but that's how I think of it, is if we took 2 and 7 and started listing out multiples, so like 2, 4, 6, 8, 10, 12, 14, 16, so on and so forth. And with 7, it would be 7, 14, 21, 28, so on and so forth there. Our least common denominator is 14. It's the smallest value that both of those denominators multiply up to. Now, that's kind of a long way of going about it, of listing all of those values out. What I would suggest doing is take the largest denominator. So like I would take just 7. Instead of writing out all the multiples of 2, especially since 2 is something we generally understand pretty well, it's all even numbers. What I would do is just start listing out the multiples of 7. So we have 7, 14, 21, 28. And really you can stop as soon as you get something that's divisible by the other denominator. So like as soon as I see 14, I would say that's an even number, that's divisible by 2, that's what I want to use. So for this, our least common denominator is 14, which means I want to create equivalent fractions. So I want to create an equivalent fraction with 1/2 and 1/7, which as a reminder, our equivalent fraction is when we multiply both the numerator and denominator by the same value. And while I'm writing those separate multiplications, really it's just one big multiplication. We're multiplying with an equivalent, a version of 1. And what I want to do is have both of these get a denominator of 14. So I have a 2 here, so that means I need to multiply by 7. So 2 times 7 will give me 14, which is perfect. Whatever I multiply the denominator by, I also need to multiply the numerator by that same number. So what this will give me is 1 times 7, which is 7, over 2 times 7, which is 14. And now I have my equivalent fraction, something that's actually equal to 1/2. It's just in this new form, so I see that denominator of 14. Then I'm going to do the same thing over here. So I want a denominator of 14. Like I want to be over here with a denominator of 14. So that means I need to multiply the denominator by 2. So 7 times 2 is 14. And whatever I multiply the denominator by, I also need to multiply the numerator by that same number. So 1 times 2, 2. So 2/14 is equivalent to 1/7, but now we have our denominator of 14. And now I can add these together like I did up above. So we'll have 7 plus 2 over 14, which is 9 over 14, and nothing to simplify there, so it would be all done. Let's do this again, and with subtraction. So 6 and 4. So what I would do is if I'm looking for my least common denominator, I take the larger of the denominators, so in this case 6, and I just list out multiples until I get to something that's divisible by 4. And if you want to list out a few things, like this would be 12, 18, 24, 30, so on and so forth, I want the smallest value that's divisible by 4, and that's going to be 12. So 24 technically also works, and you could do all of this work with creating a denominator of 24, and you would just have some simplification to do at the end. Absolutely works. It's just the numbers are going to be simpler if you use the smallest value. So our least common denominator is 12. So that means I'm going to have 5/6, and I'm going to create an equivalent fraction there. And let's see, we have subtraction here, and then I'm going to have 3/4, and I'm creating an equivalent fraction there. So I have a denominator of 12. So for the 5/6, to get a denominator of 12, I would need to multiply by 2, and whatever I multiply the denominator by, I multiply the numerator by the same thing. So 5 times 2 is 10, over 6 times 2 is 12. And then we have subtraction. And then over here, to get a denominator of 12, I need to multiply by 3. So 4 times 3 is 12, And I need to do the same thing to the numerator. So 3 times 3 is 9, 4 times 3 is 12. And now I have common denominators and I can combine my fraction. So 10 minus 9 in the numerator, keep the denominator of 12. 10 minus 9 is 1 over 12. So with those, you take the steps to find your least common denominator, then create those equivalent fractions. And then once you have those equivalent fractions, you can combine them with addition and subtraction. Our last piece here is mixed numbers. So like I mentioned in the last video, this is called an improper fraction. And it's because there are these whole pieces in there. We can count these wholes as part of, this wording is going to be terrible, but the part piece of this actually contains whole pieces. So what we want to do is figure out how many times can 3 go into 14 as a whole. So there are different ways of going about this. What I like to do is I think of, okay, 14 is not divisible by 3. Then I just start counting down. Is 13 divisible by 3? No. Is 12 divisible by 3? Yes. So if we take 12 divided by 3, that gives us a whole value of 4. In terms of a mixed number, which a mixed number is made up of 2 pieces. We have this kind of whole piece, or sorry, let's say whole number piece, and then we have a fraction piece. And the idea is that that fraction piece should not be improper. So we're adjusting this so that we don't see an improper fraction. So with this here, I just found my whole number piece. We have 4 whole pieces here. Now what I need to do is figure out what's the fraction piece. And basically that's my leftovers. So this is 12 thirds, but we had 14 thirds. So I had these 2 pieces left over out of the 3. So my thinking here is that 3 goes into 12 4 whole times. But to have 14, there were 2 pieces left over. So that's the thinking behind switching from improper to a mixed number, is just finding out how can you divide into that denominator as a whole. And so that you just kind of look until you can find a number, and you have to be counting downward. You can't count up. So it's kind of the idea of, okay, if we take out 1/3, take out another third, then we can get something that divides in evenly, but you still have those 2/3 that you removed out from there. Switching the other direction is a bit easier, and there's kind of a nice flow to it as well. And in fact, you could use this to double check if this is even correct. What we would do is, I think of going in a spiral like this. So this is equivalent to, if we have our denominator, the denominator is going to stay 3. Whatever's down there stays the denominator for your improper fraction. Then calculating the numerator, there's some work to do, and that's where we do this kind of spiral around. Now how it's going to go is you're going to take the 3 times 4. So 3 times 4, so there's multiplication there. And then here there's going to be addition. So 3 times 4 and then plus 2. So we can see we have 12 plus 2 over 3, which is 14 thirds, which checks out completely. So if you have a mixed number, let's call this capital A and then B over C. To change that to improper fraction, you would go C times A plus B. So multiply, add, and then all over that same denominator of C. So let's try that out. Over here, if we have 2 and 1/5, so what we're going to have is a denominator of 5. Then what we're going to do is multiply and add. So and going in kind of this direction. So 5 times 2 plus 1, which is 10 plus 1 over 5, which is 11/5. And that would be our improper fraction. So that's how we can convert between the two. Moving from mixed number to improper fraction, just follow that form. Starting with an improper fraction, it's a little more abstract to it by thinking of this, finding a whole number to divide in, and then thinking about what you have left over by doing that.